In this tutorial, we're going to take a look at pointers and arrays. So the stuff we're going to look at here is a little bit complicated, but as always, the thing to do is just try some of this stuff out for yourself and go easy on yourself. Like don't expect yourself to understand this all immediately, because you won't attain fluency with this until you've used it several times in your own programs that you've tried to write for yourself. But the exercises will help fix this in your mind. So let's start by declaring an array. I'll make this, let's say, an array of strings. Let's say string, I'll call it text equals. We need to put the array brackets in there, of course. Equals, and we'll initialize this with some strings. Let's say 1, 2, 3. Now, if we do size of this array, let's just try it. Cout size of text. That will give us the size of all the elements in the array, and we can divide that by the size of string to get the number of elements in the array. We've seen this before. Now, this might seem a little bit puzzling because, of course, strings have different amounts of data in them, but here we see it's correctly given as 3, which is the number of elements in the array, and yet we've got different amounts of data in each string. Well, here's 1 to 5 characters, and here's 3 and 3. But that's because the actual contents of the string is stored in some memory that the string object allocates separately. So what we're storing in the array is a string object of fixed size, and the actual text is stored elsewhere, basically, by the individual string objects. So this works for string arrays just like it does for int arrays. Now, to iterate through that, we could of course do this. Let's say for int I equals 0, I less than this stuff, basically. Let's just copy that, and I++, and now we can do cout and text I. So we've seen that before as well. This is just using normal array syntax, and it looks like this: 1, 2, 3. I'm just going to change that to flush and add an empty space here, just so we can get all that stuff on one line. Now, if we declare a pointer of type string, let's do that. Let's get rid of this line here. Let's say string pointer, and we'll call it ptext. We can set that to point at the first element in the array. And there are several ways, well, there's 2 ways to do that, basically. We'll look at the second way a bit later. But one way to do it is just to type text like this, just the name of the array. Because in fact, array variables and pointers are extremely similar to each other. The main difference is, perhaps it's even the only difference, is that the array variable actually knows how much data it's pointing at. It has that information in it, and that's why we can use size of to get the number of elements in the array. A normal pointer like this doesn't know how much data it's pointing at. It only knows the size of the first block of data that it's pointing at. It doesn't know how many blocks there are. So this pointer knows that it's pointing at a string because of this, but it doesn't know how many strings there are. It doesn't know what size the block of memory is and how many strings there are in that, whereas this does. But apart from that, this and this are basically the same, and that's why we can assign a pointer directly to point at an array variable. Now we can iterate through this array using this pointer. All we have to do here is change this to ptext like that, and that will work. So it says 1, 2, 3. That's one way of using a pointer, which is a bit surprising when you first see it, to iterate through an array. But there are other things that we can do as well. Let's take a look at another example. So one thing that we could do is let's use this for loop again, and I'll just format that. So we've left the pointer here pointing at the start of the array like this, and instead of using like array element reference syntax here, we could output the thing that the pointer is pointing to by dereferencing the pointer. So if you remember from the last tutorial, we can do that just by typing p text with a star before it. So if this pointer points at a string, then star and the pointer name will actually give us the actual value in the address that that pointer points to. That will point to the first string. So if we run that, it's just going to output the first string 3 times, 111. Let's make that a little bit clearer by outputting just a new line here. So I'll save that and run it, and we'll get 111. How can we move this pointer to point at the next string? Well, because the pointer knows what size of block of data, what kind of data block size it's pointing at, we can just say ptext. We could say equals ptext plus 1. So by adding 1 to the pointer, C++ knows that you want to make it point at the next block of data in the memory it's pointing at. So if we run this now, after saving it, then we get all the strings 1, 2, 3. And in fact, we can use the more succinct syntax that we've just used here to increment I. We can just put ptext plus, and that will also make the pointer point at the next. Each time that executes, it will make it point at the next block of data in the memory it's pointing to. So that works. Now, for loops are actually quite flexible. So if we wanted, we could put this up here, because we want this to happen once after every time the loop has run. And this, the stuff in this part of the for loop, after the second semicolon, so there's 2 semicolons dividing the stuff up here. And the third section here happens every time after the loop has run. And we can put more than one thing in there. We can put a comma and put something else that we want to run besides I++. We can put p text plus. Let's get rid of that. And that will now also do the trick. There's another way that we can do this as well, using pointers. Let's try that. So we can create a pointer to the start of the text like this, so to the start of the array. This pointer now, by the time we finish, is going to point to the end of this array because we've incremented it. So I don't want to use that again. Let's create a new pointer. Let's say string pointer p. I'll call it p element, because we're going to point this to each element one after the other. And I could set that equal to point to the first string in the array like that. And I can get another pointer, string, which I'm going to call string pointer p end. I want to point this to the end of the array. So I want to point it to the last element in the array. And I can do that. Well, how would we get the last element in the array? We'd have to know how many items are in it, unless we use size of. So the last item in this array is going to be element 2, because this is element 0, 1, and 2. Now, to get the address of this element, because we can assign the pointer to this, but that would give us a nonsense thing. That would just take this kind of element, whatever data is stored there, and put it in the pointer, but this is no use. What we want is the address of this element, and to do that we need the ampersand at the start of it. So these brackets are, I forget the exact term, but they're like the array element operator, array element reference operator, something like that. They're an operator that operates on the array variable name to get you the elements in it. This is another operator that gets you the address of stuff following it. And this works because this operator has a higher precedence than this In other words, when we type this, C++ will first do this bit. It will first execute this operator and then that one. But if you want it to be even clearer, you could put this in round brackets like that. So now we know we're getting the last element in the array and then we're getting the address of it. But we don't need these round brackets just because this operator has a higher precedence than this anyway. It will execute first. So now we've got one pointer that points to the start of the text and one of the text array, and one pointer that points to the end. If we want, we could just use the same syntax here in place of this, just to make it a bit clearer what's going on. So we can put 0 in there, and that will work. It's just identical to this. But since we're using this here, if we use this here, it makes it a little tiny bit clearer what's going on maybe. Now what we want to do is we want to loop through the array, and we want to output every element that this points to, and after every loop we want to move this to point at the next element until we find that this is pointing at the same place as this. When that happens, we want to output the element, and then we want to break the loop. So let's maybe let's try using a while loop here. Let's say while, I'll do a while true, so this would be an infinite loop unless we put a break in it. And we can do cout. We can output the first element by dereferencing this element pointer. We can say cout star p element, and we'll have, let's put them all on one line again. So I'll put empty space and then flush. Then we've got to move p element to point at the next element. So we can do p element plus plus. Then let's say if p element equals p end, if it's now pointing at the last element in the array, that means that we've just output the last element in the array, and in that case we break the loop. So this is also a way of iterating through the array that sometimes is very useful. Let's run this and check that we get the right results. It's easy to make mistakes with this. Yeah, I've got 1, 2, I've missed off 3, so I think I've done something wrong. What have I done wrong? So we pointed it at the first element, we output that, we incremented it. Yeah, I should have incremented it after I checked to see if it was at the end. So we need to output the element, and then we say, is the element that we just output the last one? If so, we'll break. Otherwise, increment the pointer. Okay, I think this will work now. Pretty confident. Let's run it. Okay, so now we get 1, 2, 3. It's very easy to make mistakes in C++, even for me. And I started doing C++ a long time ago, like 15 years or something. Okay, so we can make this even a little bit more elegant still, possibly by, we could find a way of combining this with this. We could somehow fix that up so that it would work, but then it's starting to look a bit confusing, so I think I'll leave it at this. Okay, so this has been quite a difficult tutorial, but what I'd recommend is, like I say, go easy on yourself and practice these things. First of all, loop through an array using a pointer with array element reference syntax. In other words, like this. Then try loop through an array by incrementing a pointer to the array, and then finally try looping through the array, so loop through an array, and stopping by comparing two pointers, so one to the actual element and one to the end. So like here we're comparing two pointers. We're comparing the pointer that's stepping through the array with a pointer to the end of the array, and that's how we stop the loop. So if you want an exercise, I'd say try these three things. you're going to struggle with it probably a bit if it's the first time you've seen it, for sure. And I remember the first time that I looked at this stuff, it was completely baffling. It took me a long time to get the hang of it. But if you can get the exercises working, with only looking back at this text when you need to, then you can basically rest assured that you're progressing quite well. And as I say, don't expect to be completely fluent with this until you've practiced it in actual programs that you've thought up yourself, because that's the vital step that you need to really become fluent with C++. But at the moment, just working through some exercises and getting stuff working and figuring out what bits you've forgotten or what bits you didn't understand, that is really important. I also remember that when I started programming, I could spend easily, sometimes 2 or 3 days working through a bug in my program and just not knowing why it did what it did. And one thing that helps a lot with that is doing things step by step. Write a little bit of code, then build your program and run it, and check that that bit of code works as you expect, putting some cout statements in if you want, before moving on to the next bit of code. It's really bad to write everything all in one block and then build it and run it, because it makes it a lot harder to find the bugs in it. So you should write a little step, build it and run it, and check that that works properly as far as you can tell before going on to the next step. Okay, so I'll leave you with that. We're looking at the most complicated stuff in C++ here, pretty much. But hang in there, because after this it's probably going to get easier, if anything. So until next time, happy coding.